Good morning. Today we're going to start talking about properties of chords. This is a lesson that I will cover today as well as Wednesday, so I'm going to kind of split it into two just so it doesn't take too much of your time. Before we talk about properties of chords, I just want to review quickly what a chord actually is. So the definition of a chord is here in green. This is something we were able to talk about actually together before all of this craziness. So a chord is a segment whose endpoints are on a circle. Okay, so remember we have a circle and then any segment, let's pretend that's straight. We can see the endpoints of that segment are on that circle. So that is a chord. It could go right through the center. Oh, wow, that was awful. It could go right through the center. Then it would be a diameter, which we also review here. But any segment whose endpoints lie on the circle is a chord. So any single chord divides a circle into two arcs. So this first chord here that we could see we have one arc here. That would be a minor arc because it is less than 180. And then the other arc is on the left there, which would be a major arc because it is greater than 180. If it is a diameter, saying it's going right through the center here, again, just pretend that's straight, then it divides into two semicircles. We'd have a semicircle here, so it'd be exactly 180. A semicircle here, so it'd be exactly 180. So again, anything other than a diameter will divide the circle into a minor arc and a major arc. Now that we have reviewed some of the definitions of a chord, let's move on and talk about a property. So the first property I want to talk about is theorem 10.3. That says in the same circle or in congruent circles, two minor arcs are congruent if and only if their corresponding chords are congruent. So we can see in this diagram that we have a chord EF, endpoints lie on circle O, and we have a chord AB whose endpoints lie on circle O. So we can see that chord EF does make an arc EF right here, and chord AB makes arc AB here. We can also see the tick marks on EF. So because we have tick marks on EF, we also have tick marks on AB. So those tick marks, remember, mean they are congruent. So because segment EF is congruent to segment AB, because that is true, then we can say that arc EF is congruent to arc AB. Okay? So if the chords are congruent, the arcs formed by them are also going to be congruent. So looking at an example here, if we look at example 1, it says in the diagram, circle P is congruent to circle Q, which we can see because the radii are marked congruent. We're also told that FG is congruent to JK. These guys are chords. Okay, so we can see these chords here are congruent to each other again because of the tick marks. And then we're told that the measure of arc JK is 80 degrees, which is right here in this diagram. After all that given information, we are asked to find the measure of arc FG. So because we know that FG is congruent to JK, segment FG is congruent to segment JK, we know that arc FG must also be congruent to arc JK. So because the measure of arc JK is 80 degrees, the measure of arc FG will also need to be 80 degrees. And again, that is because the chords are congruent. Looking at example 2 here, it says use the diagram of circle D. So we can see it's circle D because the center is marked with capital letter D. The first part says if the measure of arc AB is 110, so I'm going to mark that on my diagram right here. I know that AB is 110 degrees. Find the measure of arc BC. So we're trying to find this right here. I do not know that right away. Well, if you look at the diagram, you notice that you have chord AB, which is marked 9, and you have chord BC, which is also marked 9. So because segment AB is congruent to segment BC, we know that arc AB must be congruent to arc BC. So the measure of arc BC should also be 110 degrees. For example B, if same kind of idea, we know that measure of arc AC is 150. So I'm going to go ahead and mark that. That is a 5. And now we're trying to find the measure of arc AB. So a little bit different setup. What I'm trying to find is this right here. I do not know anything about the measure of arc AB other than it has to be congruent to arc BC because chord AB and chord BC are congruent. So these arcs have to be the same. So I'm trying to find this. I'm going to mark that X. Because I know that has to match BC, I'm also going to mark that X. Now hopefully we remember that an entire circle is 360 degrees. So what I'm going to do is I'm going to subtract out the one piece I do know, which is arc AC. So I know that the rest of the circle is 210 degrees. Well, the rest of the circle is evenly split between arc AB and arc BC because we know they have to be congruent. So then I'm going to divide that by 2, which means arc AB and arc BC are each going to be 105 degrees.